Hello guys, welcome back to the Quantity Surveying workshop and to another video. In today's video, we are going to be treating how to measure for the concrete work to our beams. Now, I'm sure you know what your beams are when it comes to building construction. Your beams are structures that are used to give a frame to the building. They are intersected with your columns and also they help to give support to your suspended floor. So first, before we start our measurement, we are going to be looking at how to read the drawings for our beams. So as you can see in this drawing, they've already made things easy for us by giving us the drawing for our beams. If not, we'll have to do some assumptions to kind of place realistically where some beams will be located in the drawing, which will take our time. But they've made things easy for us as quantity surveyors by giving us the blueprints, the drawings. So now the first thing we're going to be doing now is to be trying to interpret what this beam drawing is all about. So remember that the context of this building is that the building is a frame structure, meaning that since we've already measured for our columns, right, these beams are supposed to run throughout the entire building in such a way that it will chain all the columns that we have in the building. So now as you can see in this drawing, they've told us that we have how many beams here? Beam 1, beam 2, beam 3, beam 4, beam 5, 6, 7, 8. We have a concealed beam, then beam 9, beam 10, beam 11, and beam 12. Right, so let us look at the plan for the beam so that we can see if everything is in correlation. So now as you can see, this is the plan. Let me just zoom in. So this is the plan that we have for our beams, and as you can see, they've already given us the location of each of these specific beams. So you can see that this is beam 1, and beam 1 is running from this point down to this point. So you can see beam 2 is running from here to this point in such a way that the beams are intersecting. You know it is concrete work we're trying to measure, so the concrete is supposed to link throughout this beam's placement. So this is beam 1, this is beam 2, this is beam 3 from here to here. Where is beam 4? This is beam 4 from here to here. This is beam 5 from here to here. This is beam 6 from here to here. Beam 7 cuts across all this. Beam 8 is from here to here. Then where is beam 9? Beam 9 is from here to here. And then where is beam 10? This is beam 10 from here to here. Then beam 11 is from here to this end. Beam 12 is from here to here. And you can see they're giving us beam 13 from here to here. Now the reason why this section does not include beam 13 is because, as you can see, what we have here is parallel and equal to what we have here. So it means that the details for beam 9 is what we're going to be using for the details for beam 13. So these are the information, the things you have to put in mind. You have to be smart when reading your drawings, because sometimes there is no need to replicate drawings 2 times, because what you'll be seeing in one might be in some cases the same thing that you are going to be seeing in the other. So as you can see, what we have here in beam 9 is the same as what we have here in beam 13, because you can see they are opposite and equal to each other. What we have from here to here is equal to what we have from here to here, meaning that the volume of concrete here and the volume of concrete here will be the same. The only thing that might change is if the reinforcement placing inside this one is different from the reinforcement placing inside this one. I just hope you understand what I just said. Another thing I noticed is that in the drawing, the elevation drawing, and in what we've measured before, there's an opening here, right, which is supposed to be enclosed by a beam. But they didn't give us a beam placement for this one here, so we have to include it. right? We have to include it because there's supposed to be a beam enclosing the opening. Like this is the entrance, so there's an opening here, there's an opening here, there's an opening here. So you can enter like this, you can enter like this, you can enter like this before you now get to the entrance door. I don't know, you've seen buildings like that, I'm sure. So they've told us that this beam here is included in beam 10, but this beam here, this opening here does not have a beam, which is wrong. There's supposed to be a beam here for every opening that is not enclosed by a lintel. There's supposed to be a beam. So we are going to add beam here. So we are going to be saying that the amount of beams here in this drawing is 14 in number from all the errors that we've adjusted. 14 in number. So now we are now going to be beginning our measurement. Before we begin our measurement, we are going to be looking at each of the beam one by one specifically. So we're going to be starting with beam 1. Now you can see that this is beam 1, right, from this point here down to this point. Okay, I hope you can see it from this point here down to this point, and you can see how many columns are intersecting B1. This is 1, 2, 3, 4. So within beam 1 will be intersecting 4 columns. Now as you can see from this point, that's the center dimension. From this point, that's the first column down to the second column is 4008. Then the center to center dimension from this point down to this point is not given, but they give us 2 dimensions, 3943 and 637. 3943 plus 637 is going to give me 4580, meaning that from here to this point of the other beam is 4580, and then from here to here is not given. So we have to add these 2 dimensions to give us what the center to center dimension from this third column to this fourth column would be. So now let us see if what they've given to us in our drawing is correct. So now this is beam 1. As you can see, this is the details of beam 1. You can see now that what we did was actually correct. The placement for the first column, you can see this is the section of the column here down to the section of the second column. You can see the center to center dimension is 4008, similar to what we have here, 4008. So the second dimension we have from here to here is 4580, which is the same thing we calculated in our calculator, 4580, by adding this dimension and this dimension together. So the last one is 4593, which is the center dimension from this center of the column down to the center of this last column. When you add these 2 dimensions, as you can see here, 560 plus 4033, you are going to be having a total of 4593, right? So it means that what we have here in beam 1 is correct. Now let us go to beam 2. Now you can see that this is what we have in beam 2. Beam 2 is lining from this point, that's from this point down to this point, right? It is intersecting the concrete for this beam here and the concrete for this beam here. So this is beam 2. Now let us see in our drawing if what they've given to us as beam 2 is correct. So this is what we have in beam 2 from here, right? So now they told us that the center to center dimension from this point down to this point is 4008. Now you can see that there is no column here in this section. Why is that? Because if you look at this drawing, there is no column here, there's no column here. So this beam is intersecting this beam here and here. That is why they did not, in this section there was no column. This is technical drawing in your SS3, right, when you were doing section for buildings. So this will be easy to understand. Then now the center to center dimension from this point, that's from call out A down to this point, which is call out C, you can see the total is 4008. As you can see here, that is the reason why you can see what you have here is 4008 from the center to center dimension. I hope you can understand that. So that is how easy it is to interpret your beam drawing. So let us take one more example before we start the measurements proper. Let's go to what? Beam 3. So now, where is beam 3 in this drawing? Let's identify beam 3. Okay, now this is beam 3, and beam 3 is the beam running across from this point down to this point. And you can see that beam 3 is intersecting what? Two columns, this column and this column. However, at this other end, it is intersecting this vertical beam here, which is beam 10. So now, we already calculated that the dimension from this point to this point, which is from call out C down to this point, is 4,580, right? So it means that the dimension from the center point of this beam here down to the center point of this column is what? 4,580. And then similarly, we already calculated for what? The dimension for this point here down to this point, because we did the same thing for this beam here from here to here, which is opposite and equal to this side here. So when you add these two dimensions together, whatever you're going to be having here will be the same thing as what you're going to be having here. So now let's look at our section if they correlate. So now, as you can see, this is beam 3. So the first point, which is from this point down to this point, is what? 4,580. That's from this point here down to this point here. So now, from this point down to this point is what? 4,593. Meaning that when you add 560 to 4,033, you're going to be having what? 4,593. So it means that what we have in beam 3 is correct with what we have here on the plan. So now, the next thing you need to know now when measuring for the concrete to your beam is this. We're going to be looking at the what? Section of these beams. So now, if you look at this drawing now, let's use this section as an example, right? What can you see in this section? Now, you can see that in this section of the beam, this huge rectangle you are seeing like this is your beam, and the concrete moving like this is your what? Slab. So what does this tell you? It tells you that when you are constructing your beam, you have to construct your beam and your slab together. The slab, the suspended floor, is connected to your what? Beams. I don't know if that makes sense. As you can see in this section, all the section that we have here, look at this other one here. You can see the suspended floor is connected to your what? Beam. So all these things will not be new to you. If you go to the site, you will see it's there. It is very clear, right? So now, just know that your suspended floor is connected to your what? Beams, right? So if your suspended floor is connected to your beams, now how do we now calculate for our beams and our suspended floor separately? Because they are two different work items. You don't measure them together. The drawing says that when you are constructing, the beams and the suspended floor are constructed together. However, when you are measuring, you have to separate them. So now what do? When you are measuring for the concrete, what you do now is that you will cut this concrete like this. I don't want to draw on this paper, so let me just make a caricature drawing. Okay, so now let's just say this is a caricature drawing of our beam and slab. So this is our beam, right? This is our suspended floor attached to it. Because as you can see, the reinforcement for the slab is entering the what? Reinforcement for the what? Beams. So now, in order to make things easy for you when you are measuring for the concrete work for your beams and for your slab separately, what I like to do is that I will cut this part of the beam. So now this part of the beam is what we'll be measuring. As the volume of concrete for our beams, right? So now when we now measure this part of our beams, the remaining part here, we are going to be capturing it as the concrete for our what? Slab. Now the reason why this method of measurement works is because on site, when you are about to do your beams, you are doing your beams together with your slab. You don't do your beams separate, do your slab separate. You have to make sure you cast everything together. As you are doing the reinforcement for your beams, you are doing the reinforcement for your slabs together immediately after you've done all your formwork. I don't know if that makes sense. So when you are casting the concrete for your beams, you will be casting both the beam and the suspended slab or the suspended floor together. That is why this method of measurement works. So all they will just do now is to go and get the amount of money needed for the beams and the slabs, and then go and procure materials, because they have to do the two of them together. It is very important. Please take that information very seriously. So now, like I said before, we're going to be cutting this point here, and we're going to be saying that this is what the portion of the concrete will be measuring for our beams. As you can see, the shaded portion. So now this other rectangle here would now be the point or the portion for our suspended floor. I hope that makes sense. So now if you look at our section, right, they've already told us that from this point here down to this point is 450 mm. So now what that means is that from this point down to this point here is 450 millimeters, right? As you can see here, 450 millimeters. So now what would be the dimension from this point down to this point here? Let me just put a dimension line so that you can easily see it. So now what would be the dimension from this point down to this point? Now you know that the thickness of your suspended floor is usually 150 mm. So now let's just put it here. 150 mm. So if this is the thickness of your suspended floor, 150 mm, right? Now what will not be the dimension for A? Remember, from here to here is 450, meaning that this 150 mm is inside this 450. So how do we get A? We can get A by minusing 150 mm, which is the thickness of the slab, from 450, and we're going to be having 300 millimeters. So it means that the height or the thickness of this beam will be from here to here 300 millimeters. I hope that makes sense. So now you know that the thickness of your beam is the same as the thickness of your wall. And in this case, they told us that it is 230 millimeters. So now what we need to do now, since we've gotten all the parameters we need, we've gotten the thickness, and we've gotten the width, we've gotten the height. Now we need to find the total length of our beams in this drawing, so that we can get the volume of concrete needed for the beams. Remember, volume of concrete is measured in meter cube. So we're going to be needing the total perimeter of the beams, the width of the beam, and the height of the beam. We've already gotten the width of the beam and the height of the beam. Now we need to determine the total perimeter of the beam. So now, how do we determine the perimeter, the total perimeter for our beams? And we're going to be using this caricature drawing as an example for you to understand better before we start the video proper. So now let's just assume that the beams, let's just say there's a column here, there's another column here, there's another column here, and there's another column here. So let me just shade it. And the thickness of our block work is 225 or 230 mm block work, right? So now how do we determine the total perimeter of our block work? Remember, in our drawing, the dimensions given to us was center to center dimension, but I'm using out to out dimension so that it can be easy for you. So you select one side that you want to start from. So now I'm going to be starting from the horizontal side. So now what I want to do is this. From this horizontal side, it means that I want my beam to be this point here, please look at my hand. This is beam 1, right? This is beam 1. So I need to know the length of this beam 1. Let me use the darker biro. So the length from this point here down to this point, you can see they're giving us the out-to-out dimension as what? 6,000. So it means that what we have here will be the same thing as what we have here when we calculate the volume of the concrete for this beam. I hope that makes sense. So now the horizontal, now we took it to be what? Out to out. So now what will happen to the vertical? Would we use out to out or in to in this time? I want you to answer. So if you said out to out, you are wrong, because the out to out dimension has already been catered for in this point here, this horizontal beam. So now this one now will be what? In to in. In to in. Because if we are done out to out again, we have over measured, because this part has already been catered for in the what? Horizontal side. I don't know if that makes sense. So now this point now will be what? In to in, which will be multiplied by 2, because what you have there will be the same thing as what we have here. I hope that makes sense. So now the length or the perimeter for this beam from this point to this point is what? 6,000. So multiplied by 2, because what we have here is the same as what we have what here, which will be what? 12,000 meters. Now they've told us that the out-to-out dimension from here to here is 4,000. So what are we going to do now to get the in-to-in dimension? We'll be minusing what? The thickness of this blockwork from both sides. So we're going to be having 3,540, meaning that the in-to-in dimension for this beam here will be what? 3,540. So what we have here will be the same thing as what we have here. You know, we had this beam, and this beam to be 12,000, which is 6,000 times 2 for here and here. Now this one, we're going to be having for these two, the in-to-in ones, we're going to be having 7,080. So when you add 7,080 plus 12,000, you're going to be having 19,080. So it means that the total perimeter for the beams in this drawing will be what? 19,080. So now you would now what? Convert this to meters, right? And then multiply it by the width and the thickness of the what? Beam, as we've already discussed. So that is the process you go about measuring your beams. So now this is the much complicated part when you are given drawings that have what? Multiple intersections. How do you go about it? Now that is the essence of this video. That is why this video is important. So stay tuned as we begin the measurements proper. So to begin our measurements for our concrete work, most of the work we're going to be doing here is to determine the perimeter. I've already told you how to get the thickness and the height of the beam. Now we need to determine the total perimeter of all the beams from beam 1 down to beam 14. So now let's start with beam 1. Now as you can see, they told us that the measurements for beam 1 consist of 3 dimensions: 4,008, 4,580, 4,593. Now, how do we get the out-to-out dimension for this beam? Remember, I told you in our caricature drawing that you should choose one side first, and in this drawing I am choosing the horizontal side first, which is this horizontal beam 1, from this point down to this point. So I am going to be measuring this one as out to out. The dimension will be out to out. So stay with me. So now, as you can see, they've already given us center to center dimension for beam 1, right? So now what we need to do now is that we need to add this dimension, this dimension, this dimension together, and that will give us the center to center dimension from this center point of this column down to the center point of this column. Then we can now add half of the thickness of this column to this side and half of the thickness of this column to this side to give us the out to out dimension. So now let's do the math. So the 3 dimension is 4,008, 4,580, and 4,593. So we're going to be what? Bringing them down. So 4,008, 4,518, 4,593. So now we're not going to be adding half of the thickness of this column and half of the thickness of this column. So half of the thickness of the column is what? That's 230 divided by 2 is what? 115. So it's 115 times 2. So we'll now add 2 by half of what? 230. And that's going to give me what? 230. So this 130 we just did here is like saying 115 times 2. I hope you understand. So we're going to be having a total of what? 13,411. So we'll bring it to the side for easy correlation. So now this is the total length for what? Beam 1, as we've taken it to be what? Out to out. So now if you look at this drawing here, what can you see? You can see that what we have here in beam 1 would be the same thing we have here in beam 7, because they are opposite each other and they are what? Equal. As you can see, look at the orientation, right? It's like a square. What you have here in beam 1 will be the same thing as what you have here in beam 7. So we can multiply beam 1 into times 2 to cater for what? Beam 1 and what? Beam 7. I hope that makes sense. So we can now say, note, beam 1 is equal to what? Beam 7. Equals to beam 7. Therefore, beam 7 is equal to what? The same 13,411. I hope that makes sense. So now what does that mean? It means that this horizontal beam here and this horizontal beam here, we cater them to be what? Out to out. I hope that makes sense. So now the next perimeter or the next beam we're going to be looking for would be what? Beam 9. Now remember that we catered for beam 1 and beam 7 to be what? Out to out. So now beam 9 is what? A vertical beam, which is this beam here. So how are we going to be measuring this vertical beam? It will be what? In to in. Why? Our dimension is what? Center to center, meaning that this center to center dimension has entered into the perimeter that we've already calculated for our what? Horizontal beam at beam 1 and at what? Beam 7, right? Because half of the column it has already entered into, we have already catered for it at the horizontal beam at this point and at this point. So what we now need to do now is to what? Get the dimension of what? Beam 9 as in to in, meaning that we're going to be looking for the dimension from inside of this column down to what? Inside of this what? Column. So let us go to this section so that you can easily understand. So this is beam 9, as you can see here. So now they told us that beam 9 is intersected by how many columns? 1, 2, 3, 4, 5 columns. So as you can see, we have 1, 2, 3, 4, 5 columns. So now we need to add all these dimensions together to get the center to center dimension, the total center to center dimension for this what? Beam. Then after we get that, we'll now minus what? Half of the thickness of this column from both sides. Half of the thickness of this column here. So whatever we now have will be the what? In to in dimension for this what? Beam 9. So now let's measure. So for beam 9, we're going to be adding 1,178, 5,327, 4,540, and 2,040 together to give us the total center to center dimension. So 1,178, 5,327, 4,540, 2,040, and we're going to be having a total of what? 13,085. So 13,085 is the center to center dimension from this point down towards this point. But remember, we're looking for the end to end dimension. So to determine the end to end dimension, we're going to be minusing what? Half of the thickness of the column from both sides. So we'll now say less 2 by half of the thickness of the column, which is what? 230, and that's going to be what? 230. So when you do the maths, you're going to be having a total of what? 12,855. So 12,855 is the end to end dimension from this point inside of the column down to inside of what? This column. I hope that makes sense. So now it means that what we've measured now is what? This internal point down to this what? Internal point here. Now what can you see in this drawing? You can see that what we have here will be the same thing as what we have here, because they are what? Equal and what? Opposite. Remember, beam 1 and what? Beam 7, we scattered it to be what? Out to out. We are not going to scatter this one to be out to out again, because we have it to be over measurement. So this point now will have to be what? In to in. So now it means that if from here to here is in to in, it will be equal to what? From here to here, in to in. I hope that makes sense. I hope I'm not speaking grammar, and I hope it's easily understood. But if you are confused, please tell me what you don't understand in the comment section so that I can clarify. But it is very easy and straightforward. So now we'll now be multiplying what we have here, which is the end to end dimension of what we have here in beam 9 by 2, to cater for what? Beam 9 and what? Beam 13. So when we do that, it means that we've measured for the beam round this square like this. I hope that makes sense. So now we're not going to write notes. Beam 9 is equal to what? Beam 13. Therefore, beam 13 will be equals to what? This same dimension, 12,855. I hope that makes sense. So we measured for what? Beam 1, beam 7, beam 9, and what? Beam 13. So the next beam we're going to be looking at is what? Beam 10. And it told us that beam 10 is running from this point down to this point here. But remember that we've already measured for what? This beam here. We've already measured for what? This beam here. So it means that this beam 10 has been cut by what? Beam 7 and what? Beam 1, which has already been measured. So how do we now measure for beam 10 when we've already cut it by measuring beam 7 and beam 1 separately? So now what we can do now is this. Since we've measured for beam 1 separately, we can now start. Remember, I told you that the verticals will be what? Into in. So we can now measure for this beam 10 to be into in, from this inside down to this inside, because this point here we've already measured it as beam 7. This beam here we measured it as beam 7. We are not going to be measuring it, this thickness, again 2 times. That's why we're cutting it from this inside down to this what? Inside. into in. We are going to be calling that beam 10A. Remember, beam 10 is from this point down to this point here. So we're going to be first measuring this beam from this point down to this point into in, calling it beam 10A, and then we're going to be measuring for this one from this point down to this point here, and we're going to be calling that beam 10B. So the combination of 10A and 10B is going to give us the total of what? Beam 10. I hope that makes sense. So now let's look at beam 10A first. What can you notice in beam 10A, which is from this inside down towards this inside? You can notice that the same dimension that we are going to be having here will be the same dimension we're going to be having here. So in beam 9 we had a dimension of what? 12,855, which is from this inside down to this inside, 12,855. So there is no difference between beam 9 and beam 10A, because the 12,855 we had from this point to this point is also going to be it's also going to be the same dimension from inside here to inside here. So beam 10A will be what? 12,855. So let's write. $12,855. So the next thing now we're going to be measuring for is beam 10B. Beam 10B. So now what is beam 10B? Now I told you that beam 10 is this beam going like this, right? We've already measured for beam 7 like this. So now this beam 7 has cut beam 10 at this point here. So now we have to determine the length for beam 10B from this point here down to this end. So now how do we determine the length of this beam from this point down to this end? They've told us that the center to center dimension from this point down to this point is 1920, which is this dimension here, 1920. So now we're going to be minusing half of 230 from both sides to get the in-to-in dimension from this point down to this point here. So this beam is what we're trying to measure in, right? They've told us that from here to here is 1920, which is the center to center dimension. So we're going to be minusing what? Half of this beam here, which is half of 230 is 115, and half of 230 here is 115, so which is 230. So I'm going to minus in 230 from 1920 to give us the in dimension for beam 10B, which is this point here down to inside this point here. So let's measure. So for beam 10B, the center to center dimension is what? 1920. So we're going to be lessing half of the thickness of the column from both sides. Which is what? 230. And you're going to be having a total of what? 1690. So it means that the in dimension for the length of this beam for beam 10B is what? 1690, which is from inside this point here down to inside this point here. So now I told you in the beginning of the video that there's supposed to be a beam here, but it was not catered for in the drawing. So we're going to be assuming that what we have here in beam 10B is the same thing as what we have here for this unknown beam here, because they are equal and what? Opposite. So we're going to be calling that beam X because it was not given. Beam X. So now beam X will be the same as what? Beam 10B. which is what 1690. Please, if you're confused, tell me your confusion in the word comment section. These beams can get you confused easily, but if you follow this video step by step and understand it, believe me when I say calculating any beam for any complex drawing will be very easy. You cannot find content like this anywhere. Most of the content that they give you would be for simple drawings, but this drawing is very complex. So if you can understand this, then you should be able to measure any kind of drawing, any kind of beam that they brought to you to measure. So now let's move further. So the next beam we're going to be looking at is what beam 2. And as you can see, this is where beam 2 is at here. So now if you look at this beam 2, right, beam 2 is within callout A and callout what C, and they told us the dimension between callout A and callout C, which is the center to center dimension, is 4008. But remember that we've already measured for what this beam here, beam 9, and we measured for what beam 10A, and this beam 2 is intersecting beam 9 and beam 10A. So now what we'll not do now is that we're going to be removing half of the thickness of this beam here and half of the thickness of this beam here to get the in-to-in dimension for this beam here. I hope that makes sense, because we cannot be taking this one to be out to out, because we've already measured this one here and we measured this one here. If you measure this one to be out to out, then we've over measured. That is why we are making this one in towards in. I hope that makes sense. So now we've measured for this one, we've measured for this one. Now beam 2 is intersecting it, so we'll have to remove that point of intersection. That point of intersection will be over measurement. So when we remove it, we're going to be removing half of the thickness of what this beam here, or this wall, which is 230, half of 230 from both sides. So now let's measure. So like I said before, the length of the beam center to center dimension is what 4008. So now that in beam 2 is intersecting what 2 vertical beams, so we have to remove the point of intersection, which is what half of what 230 from two sides. So it will be what less 2 by half of what 230, and that's going to be equal to what 230. So 4008 minus 230 is going to be equal to what 3778. So it means that the length for the in-to-in dimension for beam 2 will be what 3778. So this beam 2 that you are seeing here, from inside here down to inside here, is what 3778. So doing that, we measured for what beam 2. Now if you look at this drawing, right, what we have here in beam 2 is similar to what we have here in beam 5, right? So now look at what we have here. Beam 5 is within callout A and C, and callout A and C, the distance is 4008, which is the center to center dimension, meaning that the center to center dimension for this beam 5 intersecting beam 9 and beam 10A is 4008, similar to what beam 2. So now it means that we're going to be minusing half of the thickness of this beam from both sides, which is the same thing we did in beam 2, meaning that what we had as the dimension or the perimeter of this in-to-in dimension for beam 2 will be the same perimeter for beam 5. So instead of remeasuring, you just go and pick what you measured for beam 2 and bring it out to beam 5. So now you will now write, note, beam 2 is equal to what beam 5. Therefore beam 5 will now be equal to what 3778. So doing this, we measured for what beam 5. So the next dimension we're going to be looking at is what beam 4. So now if you look at this drawing now, this is beam 4, from this point down to this point is what? Beam 4. So now, if you look at beam 4, what can you see? You can see now that in beam 4 is from callout A down to callout F. As you can see here, from callout A down to callout F, that is beam 4. So now we now need to determine what is the total length for beam 4, which is from this point here down to this point. Once we get the center to center dimension, we will now minus what? Half of the thickness of what? This wall, or this column rather, and half of the thickness of what? This column, because it is intersecting in beam 9 and it is intersecting in beam 13, which we've already calculated for already. So minus half of the thickness of this column, half of the thickness of this column. Now remember that we've measured for beam 10A, and this beam 4 is cutting through beam 10A. So we have to minus this point of intersection, which is the thickness of this what? Column. Hope that makes sense. So now whatever we get as the in-to-in dimension, will be minusing what? This intersection, which is what? 230, which will give us the in-to-in dimension from this point to this point and from this point to this point. So now let's do the maths. So as you can see, this is a detailed section of what? Beam 4. So we need to add these 3 dimensions together to give us the center to center dimension for beam 4. We'll minus half of the thickness of this column here, half of the thickness of this column here, to get the in-to-in dimension. Now remember I told you that this beam 4 is intersecting what? Beam 10A. So now this is beam 10A that we've measured here, that we measured before. So now we have to minus this 230 from it. We've already cut out for this thickness when we're measuring for what? The beam to beam 10A. So we'll have to minus it too. So now we have to add this dimension, and this dimension together. So 4008 plus 3943 plus 5230. When you add everything together, you're going to be having a total of what? 13,181. So 13,181 is the total length for the center to center dimension. So we're looking for the in-to-in dimension. So we'll have to less what? 2 by half of 230. And that's going to be equal to what? 230. So when you do the math, you're going to be having what? A total of what? 12,951. So it means that this 12,951 is the total perimeter from in to in, inside here to inside here for beam 4. But remember, this beam 4 is cutting through what? Beam 10A, and we've already cut out for beam 10A. So we're going to be minusing this what? Point of intersection, which is this 230 mm thickness here. So we'll now be minusing what? Less 230. So 12,951 minus 230 is equal to 12,721. So it means that what we'll be having for beam 4 is 12,721. So doing this, we measured for what? Beam 4. Now, the next measurement we're going to be looking for will be the length for beam 11. So where is beam 11? As you can see, this is beam 11 from here to this point. So as you can see, if you look at it closer, beam 11 is from this column down to this what? Point of intersection here. That is beam 11. So now, if you remember, we've already measured for what? Beam 4 and what? Beam 7. Meaning that beam 11 is intersecting beam 4 and beam what? 7. So now we need to determine the total length of this beam 11, which is from callout 4 down to what? Callout 5. Down to callout 6, sorry. So now when we add this dimension, this dimension, this dimension, and this dimension, it will give us what? The center to center dimension for beam 11, which is from callout 4. as you can see, from call out 4 down to what? Call out 6. So now after we do that, we'll now minus what? Half of the thickness of this intersection here, and half of the thickness of this what? Intersection, for this intersection here. So let's do the maths. So if you look at this drawing, this is beam 11, right? And as you can see, if you pair it with what we have in our drawing, beam 11 is intersecting what? 2 columns. This column here has been 4, and this column here has been 6, and then it is intersecting this beam here. So if you look at it, you can see that this point here is the point intersecting the beam, and then we have 2 what? Columns. So they told us that from this column to this column is what? 4,559, and then from this center point of this column down to the center point of this beam intersection is 1,946. So now we'll have to add the 2 of them together to give us the what? Total center to center dimension for this what? Beam 11. So 1,946 plus 4,559. We're going to be having a total of what? 6,505. So now we're not going to be, this is the total perimeter for the what? Center to center dimension, but we're looking for the in to in dimension for beam 11. So we're now going to be lessing what? 2 by half of what? 230, and that's going to give me what? 230 mm. So it's going to give us a total of what? 6,275. So 6,275 is the total length for this beam in to in for beam 11, from this inside down to what? This point of what? Intersection. I hope you can understand. I hope you understand that from this point down to this point. So the next beam we're going to be looking at is what? Beam 3. And beam 3 is this beam from this point here down to this point of intersection here. So now we now need to determine the length from this point here down to this point. Remember that beam 3 is intersecting with beam 13, which we've already measured, and beam 10A, which is already measured. So it means that we have to minus this point of intersection from both sides to give us the what? In to in dimension for beam 3. I hope that makes sense. So now, if you look at this, it is intersecting what? Beam 12. So now, it depends on the approach you are using. There are some might say, okay, let them measure beam 12 first. Whatever method whatever approach you use is correct. Just make sure that you are doing the right thing, and then you are taking conversance of the beams you've already measured and whether they were in to in or out to out. Very, very important. So now I can choose to measure beam 12 from this point down to this point, and measure beam 3 in such a way that I wouldn't add this point of intersection anymore, because I already counted it in what? Beam 12, right? So my beam 3 now will be from this point to this point, and then from this point to this point. It still works. All that matters is your approach and remembering how and what kind of beam you've already measured before. So now for me, I am going to be taking it that I'm starting with beam 3. So beam 3, I'll be measuring it from this point throughout to this point here. So I'm going to be measuring this whole thing as beam 3. So now how do I get the in to in dimension from this point to this point? All we need to do now is to add the center to center dimension from call out C to call out F, minus half of the point of intersection, which is half of 230. We'll do it for both sides. So let's measure. So if you look at your beam 3, you can see this is what you have in our beam 3, right? Our beam 3 has 2 dimensions here, 4,580 and 4,593, meaning that if you add these 2 dimensions together, 560 plus 4,033, you are going to be having 4,593. And if you add these 2 dimensions together, this and this, we are going to be having what? 4,580, meaning that from this point, from this center point down to this center point is 4,580, and from this center point down to this center point is what? 4,593. So we are going to be adding those two dimensions together. So 4,580 plus 4,593, you are going to be having a total of what? 9,173. So 9,173 is the center to center dimension from this point down to this point of beam 3, right? So now I'm going to be minusing what? The point of intersection, which is what? 2 by half of what? 230. Which will give us what? The in-to-in dimension for what? Beam 3, which is what? 8,943. So it means that the total length for beam 3 from this point here down to this point here is 8,943. So now we're not going to what? Go towards beam 12, which beam 12, now they told us that beam 12 is from this point here down to this point, but you can see there's a point of intersection here, which beam 12 is already intersecting beam 3. So we'll have to minus this point of what? Intersection, because it has already been catered for in what? Beam 3. So now let's go to this section of beam 12. Now, if you've been following up lately, what can you notice about beam 12? You can notice that what we have here in beam 12 is totally different from what we have in our plan. So it means that this beam 12 is wrong. Look at what we have in our plan. For our beam 12 is from this point here down to this point. So how many columns do we have? We have 1, 2, 3. Only 3 columns. And if you notice, our beam 12 is from call out 1 down towards call out what? 4. So if we add all these dimensions together, let's just do it so that we can be practical. 1,096 plus 944 plus 2,545 plus 452 plus 1,543. We're going to be having a center to center dimension of what? 6,580, meaning that the total center to center dimension for beam 12 is what? 6,580. But what we're going to be having here is totally different. So now let's add all these dimensions together. 1,946 plus 4,559 plus 1,543 plus 2,997 plus 2,040. We're going to be having a total of what? 13,085, meaning that this beam 12 is longer than the actual length of our beam, meaning that this beam 12 is wrong. That is why you have to read your drawings properly. Don't be in a haste to measure. Always read your drawings properly. So you see now that if we had followed this section to get our measurements, we would have been wrong. I have to go and check why this beam 12 was longer than what was actually in the plan. And as you can see that there's an error here. So we're not going to be using the dimensions in this section. Instead, we're going to be using the dimensions inside of what? The plan. So we've gotten the length of what? The center to center dimension for beam 12, which is from this point down to this point, by adding call out 1 to 4, and we had a total of what? 6,580. So now let's do the maths. So now for beam 12, we're going to be adding these dimensions from call out 1 down to call out what? 4. 1, 2, 3, 4, 5. All these 5 dimensions together. So we're going to be adding what? 1,096. 1,096. 944. 2,545 452, 1543. So when you add everything together, you're going to be having a total of what? 6580. So now 6580 is the center to center dimension from this point here, from call out 1 down to what? Call out 4. But we are looking for the in dimension for beam 12. So we'll now minus what? Half of the thickness of the what? Wall or the beam from both sides. So less 2 by half of what? 230, and that's going to be equal to what? 230. So when you do the math, 6580 minus 230 is equal to what? 6350. So now it means that 6350 is the in dimension from this point here down to this point. But we have to minus this point of intersection here, and this point of intersection, the length is what? 230. So we'll now less what? Thickness of beam 3. Which is what? 230. So when you do the math, you're going to be having a total of what? 6120. So 6120 is the length for what? Beam 12. So it means that if you add the in dimension from this point down to this point, and then from this point down to this point, it is going to make you a sum of what? 6120. Beam 6. So where is beam 6? As you can see, this is what we have in beam 6 here. This beam intersecting what? Beam 10A and beam what? 11. So now they've told us that the dimension from here to here is from call out C to D, as you can see in this drawing. Call out C to D, which is what? 3943. So beam C to D. So beam 6 is 3943. Right, so now we're not going to minus what? The intersection, because we've already catered for the intersection at A and what? At 10A and at what? Beam 11. So we need the in what? Dimension of what? Beam 6. So now we can now what? Measure. So for beam 6, 3943, we will now less what? 2 by half of what? 230. Which is going to be equal to what? 230. So now when you do the math, you're going to be having a total of what? 3713. So the last beam we're going to be looking at is what? Beam 8. So where is beam 8 in this drawing? As you can see, this is beam 8, this beam here. So how do we get the total out-to-out dimension for this beam? Remember that this beam 10B here, we did it in. Together with this beam X, we did it in. So now this beam now will be out towards out for what? Beam 8. So now we need to determine the out-to-out dimension for what? Beam 8. So if you look at this is beam 8. You can see that they've told us the dimension from here to here is what? 5140. So we'll add half of the thickness of this column here and half of the thickness of this column to give us the out-to-out dimension. So we'll now what? Record. So 5140. We'll now add what? 2 by half of what? 230, which will be equal to what? 230. So when you do the math, you're going to be having a total of what? 5370. So doing this, we've measured for what? All the beams to our what? Drawing. So we're not going to what? Add all the parameters together. So 13,411 plus 13,411 plus 12,855 plus 12,855 plus 12,855 plus 1,619 plus 1,619 plus 3,778 plus 3,778 plus 12,721 plus 6,275 plus 8,943 plus 6,120 plus 3,713 and then plus 5,370. What are we going to be having? We're going to be having a total of what? 119,465. So this is the total perimeter of all the beams in this drawing. So what we're going to do now is that we're going to describe and measure. So we'll describe by saying what? Reinforced in situ concrete the mix ratio is 1:2:4. Mm size aggregate in beams. So now how do we now book? We know that concrete is measured in meter cube. So we've gotten our perimeter, we know the thickness of the beam, and we know the height of the beam. So the total perimeter of the beam is 119,465, which is 119.47 meters. Then the thickness of the beam is 230, which is 0.23, and then the width of the beam is 300, which is 0.30. So when you do the maths, you are going to be having a total of 8.24 cubic meters. So 8.24 cubic meters is the total volume of the concrete needed for our beams. But we are not yet done. Remember, in this section they said that there's going to be a concealed beam, so we'll have to cater for it too. Now if you look at this drawing, right, you can see that they've told us that this is our concealed beam. This is the concealed beam here. So now how do we measure this concealed beam, and why did we not measure it together with our regular beam? Now this is the reason. Now we did not measure this concealed beam with our regular beam because the sizes of our regular beam and our concealed beam were different. That is why we did not measure it with the regular beam. The size, remember that the size of the regular beam was 230 by 300 when you look at this section. But in this case, this concealed beam is totally different. So let me bring a section so that you can see what I mean. Now if you look at this section of our regular beam here, you can see that the thickness was 230, and we cut. Normally the height of the beam is 450, but I told you that the slab and the beam are joined together, so we have to cut off the slab. So meaning that the beam we have, the height of the beam we have is 300 mm. However, look at the concealed beam that we have here. You can see it's totally different. That is why we did not join it together with the regular beam. We would have measured shambles. So this concealed beam is totally different in shape to that of the regular beams. So we have to measure this one separately. Assuming the concealed beam was the same shape as this regular beam here, this regular beam that we have here, we would have added the perimeter to the regular beam, but the shape is different. That is why we are not adding the perimeter for this concealed beam to that of the regular beam. I hope that makes sense. So now, how do we determine the length of the beam, of this concealed beam? Remember, this is the section. So when you cut through that concealed beam, this is what we have. The height, the width of the beam is 600 mm, and the thickness is what, 175. What they mean by concealed, it means that maybe the ceiling is going to be covering the beam. So when the viewer will not be able to see the beam inside of the room. So because the ceiling is covering the beam, that is what it means by it's concealed. So how do we now measure for this what concealed beam? First, remember we're looking at concrete. So the first thing now we're going to be looking for will be the what perimeter of this what concealed beam, or the length of this concealed beam. So now, if you look at this drawing, how do we determine the length of this concealed beam? They told you that the concealed beam is from what, this beam 11 down to this what, beam 13. However, we've already measured the concrete for beam 11 and what, beam 13, meaning that we need the concrete for the concealed beam to start in from inside here down to what, inside here. So now we need to determine the in dimension for here down to what, here. So how do we do that now? If you look at this, if you look at the parameters that we have here, right? If you trace this concealed beam down here, you can see we've traced it to call out what, D. That's from this center point, we trace it to call out D, and from this point to call out F. So we can add these three dimensions, 637, 560, and 4033. We can add them together to get the total dimension from call out D to call out F. They will now minus half of the thickness of this beam on both sides to give us the in dimension for this concealed beam. So now let's what, measure. So now the length, we'll add what, 637, 560, and 4033. So when you add everything together, you're going to be having a total of what, 5230. So it means that the center to center dimension from the midpoint of this beam down to the midpoint of this beam is 5230. So you will now what, we're looking for the in dimension, not the center to center dimension. So we'll now less what, 2 by half of what, 230, which is equal to what, 230. So the length of that concealed beam will be what, 5000 meters. So now we will now what, describe by saying what, reinforced in situ concrete as before described. What do I mean by as before described? Is the same mixed ratio, the same size of aggregates in what, concealed beams. So now what, close. Now how do we measure? Concrete is measured in what, volume. So we're going to be needing the what, length, the height or the width, and the thickness of the what, beam. So the length is what, 5000 millimeters, which is what, 5.00. Now if you look at our section, what is the what, width? The width is what, 600 millimeters, and the thickness is what, 175. So in meters it will be what, 0.60 by 0.18. So when you do the math, you're going to be having a total of what, 0.54 cubic meters. So doing this, you've measured for what, the total volume for the concrete in all the beams for this drawing, as well as the what, concealed beam. So with this, we've come to the end of this video. In our next video, we're going to be treating how to measure the reinforcement inside of both the regular beams and the concealed beams. So stay tuned.